Our next example comes out of section 5.1, graphing sine and cosine functions. And in this example, we're asked to graph y equals negative 2 sine 4x. I would imagine this or picture this as a transformations question, not a calculator question. If you do it all in your graphing calculator, students lose track of what they've done or don't necessarily understand the pieces of what they've done. If you start this off by thinking, what would a y equals sine x function look like? You don't even have to do a particularly accurate and beautiful job of drawing it, but I do know that it goes positive 1, negative 1, has a period of 2 pi radians, and so if I draw 2 cycles of it, it looks roughly like this. Now I might want to do the transformation of doing the reflection. Might even use the same set of axes. Y equals negative sine x is just going to be that same size of graph, same period, same amplitude, but goes down instead of up. And so with the dotted line, I've got that one. Now I would also do y equals negative 2 sine x, which is going to not just reflect it, but also vertically stretch it by a factor of 2. So your new amplitude is 2, your period is unchanged. So this thing, pardon me, is going to go down to 2, back up to positive 2, down to negative 2, up to positive 2, and look approximately like this. So the final one is the one that I'll take the most care to draw, and it's negative 2 sine of 4x. And so we will, I'll take a second to draw these axes. So what have we done so far? We've done reflect in the x-axis. We've done a vertical stretch by a factor of 2. Now we're going to do a horizontal stretch by a factor of 1/4. When we did this previously, what we decided to look at right away was, what's our period going to be? It's going to be 1/4 of 2 pi, which ends up becoming, if you reduce it, pi over 2. So this graph will do a full cycle by the time we get to pi over 2. So it still starts at the origin, and nothing we've done so far has changed that. It still has an amplitude of 2, so it's going to go up to positive 2 down to negative 2. But by the time it gets to pi over 2, it's going to do a full cycle. So if you've gotten decent at drawing sine graphs, you'll be able to draw that this thing goes down to its minimum, back up to 0, up to its maximum, back down to 0, and it does all of that by the time you get to pi over 2. So if we had to label some points, we'd have to divide this cycle into 4 pieces, which means that this first point here happens at pi over 8 comma negative 2, and this one at the top is 3 pi over 8 comma positive 2. And you could draw more and more cycles of it. In fact, by the time you got to pi, you'd have another full cycle. By the time you got to 3 pi over 2, you'd have another full cycle. And by the time you got to 2 pi, you'd have another full cycle, showing that you have 3 cycles or 3 periods by the 4 periods by the time you get to 2 pi, which makes sense since we horizontally stretched by a factor of 1/4. So your final graph could look like that, depending on the instructions they gave you, how much graph you needed to show. Usually that would be more than enough.